After getting failed in Google interview, I researched a lot about how to master or have a strong hold on each data structures and algorithms we practice. In this session, I am going to discuss one of the most important data structure called as a linked list. I will tell all the things like how to study linked list, which are the basics operations we can perform on linked list, which are the standard problems that we need to solve on linked list. Also at the same time, I will provide you the links to those problems so that you can have a strong hold on it. So just in case if you are new to the runtime error, do subscribe the channel so that you can become a better in a data structure. So now, without any further delay, let's proceed the linked list journey. So let's start how to master linked list data structure. So I'm going to discuss each module in detail, that is prerequisite, what will be the prerequisite, what type of linked list are. So I'm going to explain each and every single module in detail along with the links to the question. So stay till the end of this video. So the first point, that is prerequisite. So whenever you are coming to the linked list, make sure that you are good in arrays as well. Now the question comes, I'm moving to the linked list, then why I need this array? The point is we should understand the difference between the array and the linked list. We have the arrays, then why we need the linked list, right? What is the advantage of having linked list over arrays? What are the disadvantages? How the elements in the arrays get stored and how the elements in linked list get stored. So these things we need to get clear with. Second important thing is recursion. Now the point is we are here to study the linked list, but why do we need a recursion? Because we know that linked list is just an extension when it comes to the tree, and you cannot solve any of the problem of tree without having the recursion. So what I'm going to do is, just to make your base strong while going to the tree data structure, I will be asking you to solve the linked list questions in both the ways, that is for iterative ways and with the recursive ways as well. So make sure that you are clear with those two things, that is first one is array and the second one is recursion. This is our prerequisite. So once we're done with the prerequisite, let's move on to the type of linked list. So we know that basically there are three types of linked list. First one is called single linked list, doubly linked list, circular linked list. So what you need to do is, first, before moving on to the solving the problem of linked list, learn and implement these three types of linked list. Means what do you mean by single linked list, what do you mean by doubly linked list. Most important thing you should know is when to use circular linked list, when to use doubly linked list, and when to use single linked list. So learn these things. Third important point, you should know the application of all the three types of linked list, because knowing the applications will help you solving the standard problems of your linked list. So I hope so you are clear with these three types of linked list. Now once we have done with the prerequisites and the types of linked list, we know that there are certain operations that we need to perform on linked list. Which are they? How to take the input. Taking the input is really important when it comes to the linked list and the tree. Why? Because you should know how to create the node. If you created the node, where should you attach that node, whether it start, middle or end. So you should know these things. So after knowing how to take the input, we should perform three types of operation on linked list. Which are they? First one is insert. Then it can insert at any place. It can insert at start, it can insert middle, or it can be inserted at end. Then we should perform a search, that is whether the any particular element lies in my linked list or not. And last one is delete. Now again, delete will have the three types: delete at first, delete in between, or delete at end. And I have wrote this. You should perform these three operations in both the ways, that is in iterative ways and in recursive ways. You should not perform only in iterative ways, you should perform in both the ways, that is recursively and iteratively. Why? Because recursive implementation, for sure it will help you during a time of tree data structure. It's my guarantee for sure. Okay, so we have done with the prerequisite, then we come across a types of linked list, then we're done with the basics operation, that is insert, delete and search, right? So once we are done with this, then we're started coming to the standard problems of linked list data structure. So the first one I'm going to have is reverse operation on linked list. Now the reason is why I have inserted this reverse operation on linked list, because after getting failed in Google interview, I researched a lots of questions on linked list, and I found that these are the questions which are commonly asked in interview, right? For example, reversing the linked list, reverse the linked list in k groups. So these are the commonly asked question in interview. So I thought I should tell you that okay, these are the questions that you should never miss, because based on this question there might be a certain types of questions comes where you need the same or similar logic which we have used in this reverse linked list or k reverse linked list. So you have to perform this both the ways, iterative way and recursive way. I have given the link to the question, that once you click on this link you will be taken to that question and you might try to solve this question. And the one is as the add two linked list. So here basically what happen is that is you will be given a two linked list. So if for example this is first linked list and this is second linked list, we need to add these two linked lists, right? This is the most trickiest question, because normally what happen is, say for example, I have the one node called as 9 and another node called as 1. So if I add this, I will get as a 10. But the point is, I cannot store 10 in a single node. I will store 0 in one node and 1 in another node. So this is how I need to create the two nodes when I'm coming across two digit of number. So this is the most trickiest question, and most interesting point is, this is most amazing question as well. So these are the first go through questions for the linked list, that is reverse linked list, key reverse linked list, and add to linked list. Okay, now we are ready to go for the standard problems of the linked list. Now which are those standard problems? So I have made a list of standard problems. First one is slow and fast pointer. In this video, I'm guaranteedly telling you that 90% of the linked list problems are solved by slow and the fast pointers. Now what do you mean by slow and fast pointer? Say for example, one pointer is pointing at the first node and the second pointer is also pointing at the first node, but in one step my second pointer will go 2 steps ahead and my first pointer will just come 1 step ahead. So what will happen is, my first pointer will be pointing now my second node and my second pointer will be pointing on my third node, because it has jumped 2 steps. This is what we call a slow and fast pointer. So delete the middle node. Now with the help of this slow and the fast pointer, we know that we are able to find the middle node of the linked list, and once you find the middle node of linked list, it becomes a lot more easier to delete that node, right? So this is the fast and slow pointer. Don't miss this. This is because on this slow and the fast pointer, 80 to 90% of the linked list problems are solved. It's my guarantee, I'm telling you that. So again, I have attached the link of this question so that you want to practice this delete node in middle. And the last one is detect and remove the loop. So we know that there is one standard question on linked list, that you will be given a linked list and they will ask you to detect whether my linked list contain a loop or not. So again, the 2 pointers will come into picture. So what basically we do in this problem is, we keep a 2 pointer and just one pointer will move 2 steps ahead and another pointer will just move 1 step ahead. So at any point, if both the pointers meet each other, then we will simply say that okay, my linked list contains a cycle. So again, what come into picture? Fast and slow pointer came into the picture. So these two problems posted for you. The reason for this, just to get familiar with slow and fast pointers and how does it work. So once we are done with the start and fast pointer, let's move on to merge sort on linked list. So that's why I already said that in prerequisite that we need an array, because there are certain operations that we are going to perform on a linked list as well, like merge sort and arrays. So we know how does a merge sort works. Merge sort basically works on divide and conquer. So we have given a linked list, we will divide it, go on dividing it till we come across one node, and then start merging it, just similar in a way we did for the array. So just need to make sure that in array we used to directly divide it into the one part, that start plus end divided by 2, we used to get the middle and we will divide it into 2 parts. But in linked list, what we need to do is, first we need to find the middle of the linked list and then we will divide it. So once you need to find the middle of the linked list, again who comes into the picture? Slow and fast pointer. That's why I inserted slow and fast pointer at first and then these algorithms or these techniques at last. So this is how we should perform the merge sort on linked list as well. Make sure that you are performing it in time complexity called as n log n. Then the point is the intersection of two linked lists. Means what happen is, you will be given a two linked list, so they will be moving in this way and at certain point they will meet and the single linked list will go on, right? Say for example, this is first linked list, this is second linked list. So up to this point they will come, and from this one you will get a single linked list. So we just need to find the point at which the two linked lists intersects. So this is the one question that I have inserted, because again here you will be coming across a 2 pointer, not slow and fast pointer, but you will come across a 2 pointer. This is again one of the amazing question that I came across. And the last one is, we need to check whether the linked list is palindrome or not. So here the catch is, they will give us a single linked list, because if they have given a circular linked list or doubly linked list, it becomes a lot more easier that I will one travels from the first and another I will travel from the end and go on checking each and every single element. So this will not be possible, right? So that is the reason why, just to make your question a little bit of harder, what they have said is, they have given a single linked list. And we know that in single linked list we cannot traverse from back, we need to traverse from the front only. So this makes a question bit trickier, so you should try to solve this question as well. Now once you are done with the standard problems, which are the other types of linked list? So doubly linked list implementation, circular linked list implementation that you should perform. Because you know, one thing I will tell you that even if you simply implement single linked list, doubly linked list and circular linked list, with the help of diagrammatic and pen and paper, you are almost done with the linked list. You don't need to do anything else, because linked list is nothing but it is simply a diagrammatic data structure, I would say. If you draw the diagrams, connect the links, for sure you will get the logic how to solve this problem. So make sure that you are going diagrammatically way and implement all the three types of data structure, all the three types of linked list. It will help you solving the problem. And last, just implement stacks and queue with the help of the linked list as well. And as I mentioned, trees, that after linked list, the tree is the most important thing, because tree is nothing but the extension of linked list, I would say, right? So all these things will come into the picture. Just only a thing is, in linked list we have the node which contains two compartments, that is one for data and one for address of next node. But when you come to the tree, we will have the three compartments. Middle one is for data, left is for the left node, and one is for the right node. So this is how a tree structure looks like. But at the end, it is a linked list. At the end, it is a linked list, right? So I hope so that this video has helped you and got a little bit of path to know how to master a linked list. So if you follow this path, it is my guarantee that for sure no one can stop you mastering the linked list as well. So just in case if you are new to the runtime error, and if you found this path really helpful, do subscribe the channel and also share with your friends so that even they can master the linked list as well. Till then, have happy coding.